Hey, this is Professor Parker, and you're watching All This Math, where we solve math problems and do other things with math problems. All right, so I'm doing this video today because my nephew, Nasir, shout out to Nasir. Nasir just started doing this type of skill in his math class, right? What they're doing is they're solving equations where the variables have rational exponents, all right? Now, let's talk about that for a minute. Let's talk about what a rational exponent is. In the context of mathematics and in algebra, when you think of or you hear the term rational exponent, just think an exponent that is a fraction. An exponent that is a fraction. That's what a rational exponent is. See how this 3/2 is a fraction? You have a numerator and a denominator. That's a rational exponent. And in example number 2, you got this 3/4 right here. That's a fraction also. 3 is your numerator, 4 is your denominator. That's a rational exponent. All right. Now let's start with number 1. Our goal is to solve. Always know what your instructions are. All right. And don't always think that you're solving something, because you might not be solving something. You might be evaluating something sometimes. You might be simplifying something sometimes. All right. But here we are solving. And we know that because the instructions say to solve. All right. Now, the way we solve an equation is we isolate x by itself. Now you might be saying, well, we're already done because x is by itself. But notice what I said. We isolate x by itself, not x to the 3/2 power by itself. So we want to get x by itself. Or you really want to get x to the first power by itself, because x to the first power is the same thing as x. Right now, this is x to the 3/2 power. You want to change that to an x to the first power. So for real, what we're doing is we're trying to get rid of this 3/2, right? And when you come on these videos, I'm not only going to tell you what to do, but I'm going to tell you how to do it. A lot of times we are very confused in math classes because, for one, we don't even know what we're supposed to do, right? And then even if we know what we're supposed to do, we don't know how to do it. So those are the two main parts of success in mathematics. First of all, you got to know what to do, and you got to know how to do. And when you come to the All This Math page, I'm going to put you on. I'm going to show you what to do, and then I'm going to show you how to do it. Now, we already said what to do. What to do is to get x by itself, right? This is not by itself. This is not x by itself. This is x to the 3/2. So we want to change this x to the 3/2 into an x to the first power, because x to the first power is the same thing as x. All right. Now, how do you do that? When you're dealing with an equation like this and you have a rational exponent, you want to get rid of the rational exponent or change it into a 1. Now, the way you change a rational exponent into a 1 is you raise it to another power, right? The power will be the reciprocal. Now, that's another math term we need to know. What is a reciprocal? A reciprocal is like a fraction that's turned upside down. Think about bunk beds, right? You got 2 people sleeping on bunk beds. Somebody on the top bunk, somebody on the bottom bunk, right? A reciprocal is like them 2 people, they switch positions. The person that usually sleep on the bottom go up top. The person that usually sleep on top, they go down to the bottom. That's a reciprocal, basically. So what is the reciprocal of 3/2? Let me write that down because you should put that in your notes. That's a buzzword. Reciprocal. The reciprocal of 3/2 is 2/3, right? Because the 2 goes up top and the 3 goes to the bottom. All right. Now, this is what it looks like, and this is how you should write it on your paper. You rewrite this x to the 3/2. You put it in parentheses. Put it in parentheses. And then outside the parentheses, you apply the reciprocal exponent, right? That's what you do on the left-hand side, right? But because it's an equation, remember, whenever you solve an equation, whatever you do on one side of an equation, you have to also do on the other side of the equation. We have to be fair and we have to be balanced, because math is all about the truth. Math is all about balance and all this other good stuff. So that means I'm going to also apply this 2/3 exponent to the 8. All right. That's how I keep everything balanced. Whatever I did on the left side, I got to also do on the right side. And the equal sign is our divider. All right. Now, if we know a little bit about exponents, we know about this property in exponents called the power rule, right? Or some people call it the power, some textbooks rather, they call it the power of a power rule. So when you have an exponent inside the parentheses and you have an exponent outside the parentheses, what do you do with those exponents? You multiply them together. You multiply them together. 3/2 times 2/3 is what you do. 3/2 times 2/3. Now, if you write down on your paper 3/2 times 2/3, that's going to equal 1. And that's another part of the rule for reciprocals. Part of the definition of reciprocal is what number that could be multiplied by the original number to give you a product of 1. So the reason that 2/3 is the reciprocal of 3/2 is because 3/2 times 2/3 equals 1. That's why they're reciprocals of each other. Because when you multiply them together, you get 1, right? It gives you that reciprocity. That's why they say, like, in relationships, you need reciprocity. So everybody can be one and be healthy and be on the same page. All right? See, the math be letting you know. So look, 3/2 times 2/3 is 1. So now I got x to the first power, which is just x. I don't need to write x to the first power because look, I already told you x to the first power is the same thing as x. Now over here, this is the fun part. I like rational exponents, right? I always did. I remember back in the day when I first learned them. I like using them. Now, when you have a rational exponent, that means you're going to create a radical, right? A rational exponent tells you that you not only have to use an exponent, but you also got to take the radical or take the root of something, all right? Now, this top number right here, that's going to become your new exponent when I rewrite this. This bottom number right here, or the denominator, is going to become your root. Now, we use roots when we use a radical sign. We use roots when we use a radical sign. The radical sign is the sign that looks like a long division symbol, right? But it's not, right? So the denominator tells you the root, and the numerator tells you what your new exponent is going to be. So this 8 is going to look like this. I write my radical sign. This 3 tells me that it's the third root, also known as the cubed root, right? And I know I'm hitting you with a lot, but that's the beauty of YouTube. You can pause, rewind, run it back, fast forward it, run it back again. It's all good, right? But this denominator is the root. So I'm going to write that number right here. The technical term for that 3 is called the index. The index. The index tells you what root you're using or you're applying to the 8. This 8 is called a radicand, right? As well as being the base of this exponent, right? So that's what I do with the 3. But now you got to ask yourself, well, what am I going to do with the 2? What do I do with the 2? This is what you do with the 2. The 2, like I said, is your new exponent. So I'm gonna put some parentheses and I'm gonna put the exponent 2 outside. That's what I'm gonna do. All right. Now I could do my math. I can find the third root of 8. Now you can use a calculator to find the third root of 8, or you can just think to yourself, what does the third root really mean? It means what number can I multiply by itself again and again that will equal 8? You see I got 3 fingers up, right? The root is 3, right? So what number can I multiply by its what number do I start out with that I can multiply again and again? See, that number 3 times, that will give me 8. The number 2. 1 don't work because 1 times 1 times 1 is still 1. I tried 2. Like, this is if you didn't know how to use this and apply this and enter this into a calculator and figure it out, or you don't have the cube roots memorized, that's fine, right? You just experiment with numbers, right? So 2 times 2 times 2 is 8 because 2 times 2 is 4 and 4 times 2 is 8. So this becomes 2, but then you still got the 2 outside, which gives us 2 squared, which is 4, or 2 times 2. And that's the final answer, right? But in an equation, we should always check our work. We should always check our work. So let's try this, right? The way you check your work is you take your solution, you go back to the original equation, replace the x with that number. And then you want to tell if this gives you a true statement, because the correct answer will give you a true statement, right? Like I told you, math is all about finding the truth. That's what math is all about. So what we're going to do is I'm going to replace this x with a 4, and then I got 3/2, and I'm saying that that's equal to 8. And then I'm going to take this rational exponent, and I'm going to flip it around, and I'm going to put it into this format. So I know I got a rational exponent, so I know I got a radical. So my radical sign is right here. My radicand is the 4. The 4 goes right there. Now I got to do something with this 3 and this 2. Now I know the 3. The 3 is my new exponent. So that's going to go out here, right? But what do I do with this 2? This 2 is my denominator, which is my root, right? So that means I would put a 2 right here. But the 2 is the only root that you don't have to write. If you just see a radical sign, that automatically means you're taking the square root or the second root of something. So you can write the 2 right here, but you don't need to. Because it's just like saying x to the first equals x. You could write the 1 right here, but you don't need to. You don't need the 1. When the x is an exponent, you don't need it. So basically what I do is this. I'm saying, is this equal 8? What is the square root of 4? The square root of 4 is 2 because 2 times 2 is 4. So now I got 2 to the third power. And 2 to the third power is not 6. It's not 6. That's a rookie mistake. That's Bush League. Don't do that. 2 to the third power is not 6. 2 to the third power is 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. So we good money. 8 equals 8. All right. Now that's proof that this is a correct answer. Okay. All right. Let me erase this. And now let me take what we understand, what I showed you in number 1, and let's apply it to number 2. So let me erase my check. And remember, whenever you solve equations, do yourself a favor. Always check your work. Always check your work. It's a good habit. Right? All right. Now, number 2. We have 2x to the 3/4 power equals 54. All right. Now, again, our main goal stays the same. Remember, I told you, I'm going to tell you what to do and how to do it. All right. What we do is we want to isolate x to the first on the left side of the equation, or wherever the x is, right? Right now it's on the left side of the equation. I want to isolate it. So I got to get rid of some things. First thing I'm going to get rid of, though, is this 2. This 2 got to go. Then I'm going to get rid of the 3/4, right? In this problem, I only had to get rid of the 3/2, right? Just the rational exponent. But in this problem, I got to get rid of the 2 and the rational exponent, all right? So how do I get rid of the 2? I do the opposite operation. This 2 is being multiplied by the x. So that means I do the opposite of multiplication, which is division. Right. So I do this. Divide by 2. And again, we're dealing with equations. We're dealing with balance. Whatever you do on the left side, you got to do on the right side. So I go over here. Divide by 2 over here. 2 divided by 2 is 1. Those are 1s. So now I got x to the 3/4 power. Over here, 54 divided by 2. You got to know a little bit of math. 54 divided by 2, that's going to be 27. If you don't believe me, break out your calculator. All right. 54 divided by 2 is 27. And now we got x to the 3/4 power equals 27. All right. Now I got to get rid of this exponent. So the way I get rid of that exponent is by applying the power rule and raising this term to the power of the reciprocal. The reciprocal. Because that's going to turn this exponent into a 1. What is the reciprocal of 3/4? Reciprocal of 3/4 is 4/3. Just flip it upside down. That's all you do. To find a reciprocal, you just flip the fraction upside down. That's it. So now I'm going to do this. I got x to the 3/4 to the 4/3 power. I do that on the left side. Now I got to do it on the right side. Whatever I do on the left side, I got to do on the right side too. So I got 27. Raise that to the 4/3 power. All right. Now these 4's cancel out. These 3's cancel out. Now I just got x. All right. Now 27 to the 4/3 power. Again, rational exponent. Same situation I had right here. Rational exponent. Just a different exponent though. Now I got 4/3. So now I'm looking at a radical sign. Throw the 27 in there. And now this is like, all you're really doing is you're just trying to figure out where your numbers go at. Right. You just got to know where to put everything. This is like you cleaning up your room. That's all it is. Right. You just like, okay, where does 4 go at? The 4 going to go outside. Because when we apply rational exponents, that numerator becomes our new exponent, right? Just the numerator becomes the new exponent. The denominator becomes the root of the radical. Now, this is a 3. It's not a 2. So I have to write it. Over here, where was I at? Where was that? Oh, I erased it. I'm tripping. Yeah. When we took the square root of something, we didn't have to write the 2 as the index. We didn't have to, right? We didn't have to. But if it's a 3, you need to write the 3. If it was a 4, you need to write the 4. If it was a 5, you need to write the 5, and so on and so on. The only index you don't need to write is 2. All right, so check me out. the cube root of 27 is 3 because I know that 3 times 3 times 3 is 27 because 3 times 3 is 9 and 9 times 3 is 27. All right, so that's going to become a 3, and we still got the exponent 4 out here, right? Now again, I told you about them rookie mistakes. 3 to the 4th power is not 12. 3 to the 4th power is not 12, right? Don't feel bad if you got to count with your fingers. Do the multiplication with your fingers. Don't feel bad. Accuracy is key. 3 times 3 is 9. 9 times 3 is 27. 27 times 3, 81. So x equals 81. All right. Now, let's go back and check our work real fast. All right. So we go back to the original equation. Put my check right there. Check mark. 2 times 81 to the 3/4 equals 54. All right. Now, remember order of operations. Order of operations. You can't multiply this 2 by 81 first. You can't do that. Don't do it. Nah, you got to deal with the exponent first. Remember, PEMDAS. Even though sometimes you can divide before you multiply, all right? But that's the subject of another video, right? Apply this exponent first. So I'm going to do 2, and then I'm going to multiply that by, okay, I got the 4th root of 81 to the 3rd power. The 4th root of 81 is 3. How I know that? Because I just did this right here. 3 to the 4th is 81. So the 4th root of 81 is 3. So then I do 3, this turns into a 3 to the 3rd power, which is 27. And I got 2 times 27. And my question is that equal to 54? And it is. So that's proof that number 2 is correct. So I just wanted to go over this. Nasir, I hope this helps you out. And when you take a look at this, put your classmates on. All right. Tell them to hop on the wave, right? All this math, right? This will help them too, all right? Don't keep it to yourself. All right, so, yeah, just a little bit about how to use rational exponents, how to get rid of rational exponents, all right? How to use that rational exponent and flip it into a radical with an exponent outside, all right? And also how to check your work, all right? All of that is really important, okay? Again, thank you for tuning in. And remember, there's all this math all around you. Peace.